So, with this, on the quiz, like I said, these generally get mixed up together, the permutation, combination, or fundamental counting principle. So permutation and combination are when you are selecting out of a group, and P is for when what you're choosing are all different or in order. Combination is for when they're all the same or the order doesn't matter. Fundamental counting principle is when you have options that you are putting together and then you just multiply the options. So the first one, 45 applicants for 3 jobs, computer programmer, software tester, manager. Which one's that? P. It is 45P3, which would be something. Then second one, jewelry store sells gold and platinum rings. Each ring is available in 7 styles with one of 7 gemstones. So what would that be? Fundamental counting principle. FCP. So you would just do 2 times 7 times 7. Then a field of team hockey players needs to choose 3 players to fill the water cooler. C, because they're choosing 3 out of 15, but they all get the same job. And then a sandwich shop has 3 types of sandwiches, can be ordered on multi-grain or white bread with 6 available toppings. Fundamental counting principle, which would be 3 times 2 times 6, or 36. Huzzah. Okay. Then you've got your basic probability. So for the first one, you don't need, it's pretty simple. It's just marbles in a bag, right? So if you're looking for the probability that the marble you choose is red or blue, you would just put, there's 5 red and 4 blue, so there's 9 that are red or blue, over the total number, which is 14, which is 0.64. For these ones, there can be overlap. So I recommend writing out your sample space. So for example, you have 5 nickels and 6 dimes, which means you've got 11 total. So whatever your probability is going to be over 11. There are 2 of the nickels and 2 of the dimes are Canadian. The rest are US. So you randomly select a coin. It is a dime, so all the dimes, or it is Canadian, which would be 8, 9, 6, 8, just 8. 8 out of 11. Or 0.72. Okay. So this is the new stuff for today. Probability of multiple events. Essentially, when you're finding the probability of 2 things happening, like one then the other, you just multiply the probability of each event, like together. But the one thing you have to be aware of is whether or not the 2 events are dependent or independent. So, dependent. Okay. So, basically what that means is what you do during the first event going to impact the probability of the second event? So it could be just 2 things that have nothing to do with each other, but like if you're choosing 2 things, for example, it will be dependent if it is, without replacement is kind of what you're looking for. Meaning, so you take something out and you don't put it back, so the total has changed. Like what's in the bag has changed. That would be dependent event. When they're independent, it can either be with replacement, so you take something out, but then you put it back. or just unrelated events. Like one or the other, you know. So examples, oops. Second. Examples. Okay. So all of them today are going to ask you to say whether it's dependent or independent, and then find the probability. So for the first one, you've got a drawer of socks. There are 6 white, 4 brown, and 2 black. You randomly pick a sock and you put it on your foot. So that right there tells me that it is going to be dependent because you took a sock out and you didn't put it back. Then you pick another sock and put it on your right foot. So what's the probability that you've got a white sock on your left, or white for the first sock, and then brown sock on your right? So the probability of getting a white sock is 6 out of 12. So 6 white socks, 12 total. But then if it's dependent, let me move that over. Dependent. You're changing what's in there. So regardless of, we're going to assume that the first event happened the way that we wanted it to. We're going to assume that what was taken out was a white sock. So that means now there's only 5 white socks left. So the probability then of getting a brown sock is 4 out of 11. Does that make sense? It's 0.18. Okay. Well, the second one, okay, you flip a coin and then roll a fair 6-sided die. Those 2 events have nothing to do with each other. They're completely unrelated. So this one is independent. So the coin lands heads up. That's just 1 out of 2. And you roll a 1 out of 6. You roll 1 on a 6-sided die. That's 1 out of 6. So does that make sense? Then you just multiply them together and you get 0.08. Okay. So this one, you select a card from a standard shuffle deck of 52 cards. You return the card. So this one is independent because you put it back, shuffle it again, and select another card. Both times the card is a diamond. Note that 13 of the 52 cards are diamonds, in case you didn't know that. So that would just be the chances of getting a diamond the first time is 13 out of 52. And since you put it back, the chances of getting a diamond the second time are 13 out of 52. When you start looking at probabilities with cards, I don't know. I think it's interesting if you play card games. You know, if you're ever playing a game, you're like, man, I just need a diamond. And then, like, if you think of all the diamonds that have already been played, chances of getting a diamond, like, goes down. Anyway, that's beside the point. Okay. So, a basket contains 8 apples and 5 peaches. You randomly select 1 piece of fruit and you eat it. So you're not putting it back. So this would be dependent. Then you randomly select another piece of fruit. Both pieces of fruits are apples. So the probability of getting an apple the first time is 8 out of 13. Because there's 8 apples and 13 total pieces of fruit. So we're going to assume that we did get an apple the first time, so that 8 changes to 7. So the probability of getting an apple the second time is going to be 7 out of 12. Make sense? Okay. And then you just, see what that equals. .35. Cool. So that's basically it. Multiple events. Huzzah.